Hey there, Joel here. Time for day 8 of the advent of code. Let's click on day 8 and see what it has in store for us. I heard you like registers. You receive a signal directly from the CPU because of your recent assistance with jump instructions. That was day 5. I don't remember day 5. Would like you to compute the result of a sequence of unusual register instructions. Each instruction consists of several parts: the register to modify, whether to increase or decrease that register's value, the amount by which to increase or decrease it, and a condition. If the condition fails, skip the instruction without modifying the register. The registers all start at 0. The instructions look like this: B increment 5 if A is bigger than 1, A increment 1 if B is less than 5, C decrement minus 10. C increase minus 20 if C equals 10. These instructions will be processed as follows. Because A starts at 0, it is not greater than 1, and so B is not modified. A is increased by 1 to 1 because B is less than 5. Is now. C is decreased by minus 10. Okay, so decreased by minus 10 adds 10 because A is now greater than or equal to 1. It is 1. C is increased by 20 because C is equal to 0. After this process, the largest value in any register is 1. You might also encounter less than or equal to or not equal to, not equal to. However, the CPU doesn't have the bandwidth to tell you what all the registers are named and leaves that to you to determine. What is the largest value in any register after completing the instructions in your puzzle input? And let's look at the puzzle input. It's probably just a bunch of these. Okay, good. So this seems pretty reasonable. Let us add day 08 registers.py. And let us zoom in a few times. Good. And as always, I will copy this URL. And as always, I have been thinking about this problem while I was reading it aloud to you. And I know that I have some arbitrarily named registers and I want to keep track of their values. That tells me that I probably want to use a default dict, which is in collections. And similar to previous ones, I want to be able to I want to process these test inputs equals, and so again, as we did in a previous day, this may be overkill for a problem like this, but I like to code this way. Is that I'm going to named tuple. So I'm going to make a named tuple and parse these things into it. And what is that named tuple going to look like? I don't want that system parameters. These all look like instructions. So let's call that instruction. Class instruction is a named tuple subclass. And what is it going to have? It's going to have a register, which is a string. It's going to have an operation, which will also be a string. It's increment or decrement. I could make like an enum type for that. Amount, string, actually amount will be an int. So that'll be the +1, -1. And then condition, which is going to be, I'll call that a condition. And so this is a little bit maybe classier than you would. Class condition is also going to be a named tuple than you would usually do in Python, but I actually really like this this kind of coding. Register, comparison, I'll make this a string too, and target is going to be an int. Okay, and so now what do I want to do? I want to do parse one of these instructions, parse instruction, which will be I'll just call it raw, which will be a string, and that will be an instruction. And I'm not going to get super fancy here. It looks like all of them have an if with a space in them. So I'm just going to say, instruction condition equals raw dot split on that if. And I don't think there's a possible way to have an if elsewise, right? So now, once I do if, I've got this a inc1, and and I can do the following. If, and this is a little bit hacky, but if ink is in the instruction, then what I want to do is I want to do a register and amount equals int.split on ink. So that was, if I have ink1, I split on that. Otherwise, elif dec in inst register comma amount equals inst dot. Let me do it this way actually. Operation amount. Oh, actually, let me. Operation equals ink inst dot split dec. Operation equals dec. And then otherwise, raise value error cannot parse. What did I call that? Inst. So that's fine. And then we also want to parse the condition, and so how do I want to do that? I want to split that, and again, it's saying that the conditions are going to be, let's just say, what did I call that? Operation. So let's import regex, import re. Let's say op regex equals or less than or greater than or this might not work. Let me try this actually. IPython import re. Let's just say op regex equals equals or not equals or less than or greater than or less than or equal to or greater than equal to. Was that all of them? I think it is. So re dot find all op regex and let's say x less than equal to 4 and also z is not equal to 5 and also c is less than 6. Okay, so that didn't work because maybe because I had these too early on. So that worked better, and it looks like that is okay. So the issue there was that I put this less than before the less than or equal to, so it was matching it and then saying I'm done and then not looking at this thing. So I think with this way it should work. And so let me make sure. I'm not that good at regexes. Re search op regex 5 is less than or equal to 2 dot group. Is that right? Yeah. Okay. So operation is going to be re dot search op regex cond dot group, and then I think I can also do re dot split op regex 5 less than or equal to 2. Okay, and then let's say cond register cond target equals re dot split op regex and cond. And then what do I want to do? I want to return the instruction register equals register. operation equals operation, amount equals, and I'll cast this to an int amount, and then let me just do condition equals condition, and again register equals cond register, and what do I call it? Comparison. I called it operation. Well, whatever. Comparison equals op, and target equals int of cond target. And so this is condition equals condition. So this is probably a lot more work than you do if you're trying to solve this problem as quickly as possible. You just use like tuples and stuff and parse things cheaply. But you know, let's just add for line in test inputs dot split on new line. Let's print parse instruction line just to see what it's doing. Run day. This is from typing import name tuple. Okay, good. And just make sure it's parsing these things. Too many values to unpack. So cond register, cond target use re.split. Too many values to unpack. Okay, that's fine. I'll just print the condition and see how it goes. Whoops. The condition is a bigger than 1, so that's a good condition. Too many values to unpack, expected 2. So re opregex re.split opregex a less than 1. Oh, interesting. So re.split gives me all of them. I did not know that. Okay, good. Well, that's even easier then, because what I can do is say like that. So let me try running that, and so increment b by 5 if the condition is a bigger than 1. Let's make sure that's right. Increment b by 5. It's can't even see that. Increment a by 1 if the condition is, and I need to add a strip there, which is fine. If a is bigger than or equal to 1, yes, and if c equals 10. So let me go back and add a strip in, but I think that's otherwise good. Okay, good. So, does not like my indentation, but that's fine. So now what I want to do is I want to def process instructions. So let's get from typing import list. Instructions is a list of instruction, and it's going to return a dict from string to int. So we're basically just going to run through these instructions and process them one at a time. And to do that, let's actually write process one instruction. Instruction is an instruction, and let's say registers is a dict stir comma int, and it's going to do nothing. It's going to modify the registers in place, right? So condition equals instruction dot condition. Let's just say passed equals false. We're just going to check whether we pass condition, and this is going to be some ugly code. but that's fine. And so what we're going to say is that the value is going to be registers, and we don't actually need a default dict. We can just say registers get condition dot register 0. Okay, so we're going to look up the value that we care about. Target equals what is the target? The target is just condition dot target, and now I'm just going to op equals condition dot, condition dot comparison. I'm going to call it op because I'm going to type it out. If op equals this, past equals target equals value. Let me do it this way. Value equals target. So elif op is not equal past equals value not equal to target. And I should probably put this in its own function, but actually I will do that. Def let's call this meets condition. So I have some condition, and some registers which are a dict from string to int, and this will be a bool. Let me do the following. Move this up here. So the value will be the registers get the condition.register 0, the target is condition target op, and then I can just return this. So if it's equal, that return value equals target, elif op equals return value less, and there's probably like a slick way to do this using some voodoo, but we don't need to do voodoo, we'll just write these if statements. Return value less than or equal to target, elif op equals bigger, return value bigger than target, and then elif op equals bigger than or equal to, return value bigger than or equal to target. Else, raise value error, unknown op, make that an F string. Okay, so I think this meets condition is pretty good. So if meets condition condition registers, that's the only time we want to do the instruction. So register equals instruction dot register, and what did I call it? I called it operation. So I'll call it op again. I'm using op two different ways, which is bad. Equals instruction dot op amount equals instruction dot amount, and let's just say the current value equals registers dot get register comma 0. So if op equals, and we said these are either increment or decrement, right? So if op equals inc, registers register plus equals value plus amount. Elif op equals dec, registers register equals value minus amount. And let's just say print registers. I'll take that out in a minute, but and finally, let's say def process instructions. I have some instructions, which is a list of instruction, and it's going to return a dict from string to int. What we'll do is we'll just say registers is a dict from string to int, and it'll start empty, and then for instruction in instructions, process instruction registers, and then return registers. So that should be fine. And you know what? I'm actually going to take this print statement out of here, and I'll just print registers here. That's easier. And so finally, you know, so let's say test instructions equals parse instruction line for line in test inputs dot split on new line, and then let's just print process instructions test instruction inputs test instructions. Okay, so that's a lot, and I didn't write any tests, which is bad, but return value less than target, line 53. I don't know why I put colons here. That's a strange thing to do. Okay, let's try it again. Instruction has no op, so that's right because it is operation. So A1, A1, C10, A1, C minus 10, A1, C minus 10. So A1, C minus 10, C10. After this, the largest line in any register is 1. You might also, what is the largest value in any register after completing the instructions in the puzzle input? Okay, so question is whether I want to write more tests or whether I just want to run this thing. And part of me wants to run this thing, but let me just read the instructions one more time. A is bigger, less, bigger than or equal to, less than or equal to. Do I want to? I've lost my. Let's run it and see what happens. Get your puzzle input. Save as Joel G. Advent 2017. Save as day 08 input.text. Okay, so you know if name is main with open day 08 input.text as f instructions equals parse instruction line.strip for line in f, and then let's do process instructions. So that's going to print a lot of stuff, and let's see what happens. So let's actually add more debugging. Print checking value op target, and then let's just say print meets condition, and then let's do print register op amount. Print previous value, and then let's do print new value. This will just allow us to sanity check some stuff, and registers, register, and I should close that quote, and I should probably close the other quote too. And I hate the way it does these double things, but okay. So here, so let's look at the last line here. If v is bigger than or equal to negative 1921, so we're checking if v, which is negative 1915, is bigger than negative 1921, that meets condition. I went to VKG increment by minus 257. Previous value was this. New value is that. And so VKG is negative 943. And here VKG was negative 686. So that looks good. Let's spot check a couple other ones of these. So checking, not equal to meets condition. That seems pretty good. Checking negative 1266 is bigger than or equal to that. Doesn't meet condition. Doesn't meet condition. Meets condition. GA decreased by that previous. So I think these look pretty good actually. So I'm curious to try it and see if it works. So let me. This is only part one, isn't it? Gosh, this is gonna be a long video. All right, that's fine. So let's say registers equals this, print registers, and then I want to print the largest value, is that right? I have to process the largest value in any register. So let's print max of registers dot values. And now let's go run it again, and I want to remove some of these more print statements as well. Too many print statements. All right. So 5215 is IC. So let's try that. 5215. That's the right answer. 1 gold star closer to debugging the printer. Return to day 8. Okay. So to be safe, the registrar also needs to know the highest value held in any register during this process so that it can decide how much memory to allocate. For example, in the above instructions, the highest value ever held was 10 in register C after the third instruction was evaluated. Okay, so let's go see how we can change our code to get the highest value ever. Well, okay. Let's just say highest value ever equals float of negative infinity. Let's highest value ever equals the maximum of highest value ever and the max of registers dot values. And let's just print the highest value ever. And we should probably return it too, but this will work. I missed a parentheses there. Let's try this again. So print registers and print highest value ever. Let me just print both and then I can take a look. So this last one is not part of it. So let's see where the 6419 appears. So 291, 6419, and it's even gone by now. 6419, where are you? BY, then it goes back again. Anyway, 6419, 6419, 6419, 6419. And this is just the print at the end where that's the highest one that is still there. So let's do 6419. this is probably right since the previous part was right. And that's the right answer. We're 1 gold star closer to winning. So that's great. Thanks for watching. If you want to find me on Twitter, that's where I always am, and I'm at Joel Grus, and I will record another video pretty soon.